Good morning. Hi, everyone. Good morning. Welcome to our webinar, A Deep Dive into Generative AI Using Databricks. My name is Maria Alvarez. I am the VP of Sales for Focal CXM. A few housekeeping things. Before we get started, I wanted you to know that we will have time at the end for questions or comments. So please post your questions in the QA link and we'll address them at the end of the presentation. Today, we will explore how generative AI and Databricks combine to drive scalable intelligence solutions. We're very happy to have Venkata Jyothi Kotra with us today. Ms. Jyothi is the Director of Data and AI at Focal CXM and oversees the data and AI solutions in both the commercial and the public sector. Additionally, she serves as an adjunct faculty member for the data analytics at South New Hampshire University. Specializing in data modernization, governance, and enterprise modeling, she integrates data, analytics, and machine learning for sales, marketing, finance, and operations. Her expertise spans big data, cloud computing, distributed processing, system upgrades, and business processing transformation. Thanks for being with us here today, Jyothi. I will pass on the floor to you.
Thanks, Maya, for the introduction. I am Venkata Jyothi Kotra. Thank you all for joining today's webinar on deep dive into Gen AI using Databricks. We would dwell deeper to learn expert design patterns of LLMs like prompt engineering, retrieval augmented generation, which is popularly known as RAG, fine tuning, and explore the power of Unity Catalog, MLflow, Mosaic AI, and more cutting edge tools available on Databricks. Here is a quick peek at the agenda and topics to be discussed today in the webinar. First, we'll start with the introduction on Focal CXM, then move on to Gen AI on Databricks, and then I would showcase a deep dive demo on how to implement LLM, followed by Q&A session. Focal CXM is dedicated to enhance employee and customer experiences through utilization of data, artificial intelligence, and Salesforce. Focal CXM has achieved success in delivering diverse data and AI services to esteemed clients and stakeholders. In addition to that, Focal CXM and Databricks are trusted partners and play a crucial role in advancing lakehouse architectures and Gen AI capabilities, enabling organizations to harness data effectively while maintaining trust and compliance. Now let's go on to the topic itself. How does Databricks support Gen AI lifecycle? So the key components on Databricks itself. First, let's start with Unity Catalog. Unity Catalog is a key tool which is a single unified platform on Databricks for governance, discovery, versioning, access control, and features, models, functions. Everything is governed by Unity Catalog, and the whole Gen AI lifecycle is being managed by Unity Catalog on Databricks. And then the next component is MLflow. MLflow is mainly for the model development, tracking, and evaluation. So this maintains the whole structure of the ML machine learning and as well as LLM development. Mosaic AI model serving is another component, and this is mainly for deployment of the LLMs as API endpoints. So once the LLM solution has been built, it has been fine-tuned or implemented as a RAG solution, then Mosaic AI model serving would serve this particular model as an endpoint so that it can be integrated to front-facing web applications or even to the search applications. So irrespective of the use case, Mosaic AI model serving would turn the whole solution into an API endpoint so that it can be integrated to any nature in the downstream applications. Then foundation model APIs like Databricks has several models which are open source, which are available in Hugging Face, which can be integrated directly in Databricks, and they are available right away as model endpoints, which can be leveraged for any use cases. I would showcase this in the demo. And then the next component is Mosaic AI vector search. Most of the Gen AI community and LLM community know how important the vector search and indexes are for the LLM performance and retrieval. This is the foundation or baseline or backbone of the whole implementation of LLM, and it leverages both the retrieval and as well as generation of the prompts. And then next important component is monitoring, of course, for the performance of LLM, and make sure that not just the deployment of the solution, but the solution needs to serve at its best capability for the end customers. That's how monitoring comes in. It's very important to evaluate the LLM model for its quality on different metrics so that it performs by groundedness and serves as truth and compliant. And then Playground is another component which helps in testing the LLM model itself. So there's a use case which comes in, and then for them, there's lots of open source models available in today's market. Which model actually helps the particular use case and how I can build it? This is a starting point where different model endpoints have been exposed by Databricks, and then we can test the LLM models, and from there choose the right model which fits into that particular context or use case. Mosaic AI model training as well as Mosaic AI evaluation. This is nothing but the unified platform which framework which is on Databricks, so that it can help a model, LLM model, not only by RAG, but also we can do a fine tuning on that particular model using Mosaic AI model training. And agentic evaluation is nothing but there are several Databricks agents which can be deployed. So, as an additional LLM to evaluate the base LLM. For example, if I'm trying to use GPT-4, or if I'm trying to use a model like DBRX or Llama 3 as my primary LLM, and then agentic evaluation is nothing but deploy a supporting LLM to evaluate the primary LLM, so it can get the evaluation metrics. So that's how Mosaic AI agentic evaluation works, which we will see in the demo next. And moving on to the next concept, which is LLM application design patterns. So we heard a lot about LLMs, and then various industries trying several options on deploying this LLM solutions. But still, there is it's unknown black box scenario where is prompt engineering sufficient, or what kind of design pattern do I have to implement? So there's three types of design patterns which are very popular in the market today. One is prompt engineering. This is using the LLM as is. The LLM would have been trained, for example, GPT-4 or Llama 3. It would have been trained with n number of dictionaries and n number of languages and n number of open source internet-wide data. So it already has a knowledge base. So prompt engineering is nothing but using the same knowledge base and deploying the LLM as is. So that way, it can help with the enterprise level solution. So this would best fit in scenarios where the LLM can just use the internet wide based data and then retrieve the response. So it is definitely advantageous because it is cost effective, which means that there's no budget, there's no need of additional resourcing, technical expertise, but just deploy the LLM as is, and it is fast prototyping. But there are many shortcomings, which is like when a specific question related to enterprise is asked, it can hallucinate. RAG is the most popular design pattern nowadays in the market. RAG stands for Retrieval Augmented Generation. So here the LLM is taken, and that LLM would be trained with the external data sources. So which means that there's a bank, and then it needs to implement a bot to the front facing application, or there's a customer service industry or a retail application, and they need to deploy a bot to their front facing application. So it would be very relevant for the bot to understand and respond just like human in nature, just like how a customer service representative responds to the questions or telephonic calls. So the customer service representative has a knowledge base of a particular company. Just like that, the bot also needs to have a knowledge of that particular enterprise level data. So here we are trying to train the LLM with the enterprise level data, connect the LLM with the external sources, and then from there train it with that knowledge base. And then RAG can also take in the real time data inputs as well. And then from there it tries to get the responses, generate the responses. So this will prevent many of the hallucination scenarios for the LLMs. And it is advantageous just because the cost is relatively low compared to fine tuning, and in addition to that, there's no need of highly technical expertise, but it is very easy to deploy and handle. The last design pattern today I would like to discuss is fine tuning. It's the best design pattern for sure for any of the industries in today's world, like healthcare or life sciences or retail or banking. But here the shortcoming is that fine tuning takes time, cost, and resources. And the return on investment on the fine tuning may be a little less, and the cost associated may be high. But it is best because, like, you're trying to train the LLM, tune the LLM, like you're tweaking the LLM as well, training the LLM with the data as well as tweaking some parameters and trying to introduce some more training parameters to the LLM so that it can effectively work and have more predictable outputs, and then try to tune it, tone it, and format it so that you want the LLM to work as per what your requirements are. So that is fine tuning of LLM. Today, the whole demo and the topics would totally go over the RAG approach. RAG is one of the design pattern which I have discussed. So we are going to dwell deep into this RAG approach using Databricks. So what is retrieval? What is augmentation or generation? Retrieval is nothing but an end user actually asks a question to an LLM or a chatbot, and then that user request would be taken, and then it processes through external enterprise source data, and then from there it tries to fetch the supporting data to that question. So if I ask a question on what is RAG, then it tries to go and search for the enterprise level data set and then tries to find the answer for that, and from there it tries to generate a prompt. So augmentation retrieval is nothing but, you can just take like even an example of SQL. Write a query, SQL database process it, and then fetches a response, and then it retrieves the results. So retrieval is, here the retrieval is more powerful, where it comes from a vector store or vector indexing or keyword search. The search is more powerful here, and it is more powerful just because of the keyword hybrid semantic search combined with the LLM capabilities. So the search goes and gets in the information, and documentation is nothing but the retrieved information would be combined with the supporting data, which is metadata of that particular document from where this response has been coming from, and then it adds to the user question, and then it formats it such a way that it can create a prompt. And generation is nothing but that same prompt would be passed on to LLM so that it sends as a response to the user question. So that's the whole flow of how RAG would work. And the main fundamental concepts of RAG are data pipeline, which means that it tries to completely convert. So there are different kinds of formats of how RAG could be implemented. Like it can handle PDFs, it can handle unstructured, structured data, it can directly talk to a database, or we can process in any kind of data formats into the RAG pipeline. So data pipeline is the key, because how effective the vectors and chunks are, that much effective would be the whole solution of RAG. And the next is RAG chain. So here the RAG chain is nothing but the whole process how I have explained in my previous slide. Understand the user question, then it tries to retrieve the data from the whole knowledge base, and from there convert that data, which is ideally in a vector or numerical representation or mathematical representation, convert that back into a contextual level, and then attach it to the metadata of that particular document and send that response back to the user. So that whole thing happens in RAG chain. And next next step is nothing but evaluation. So here, not only just deployment of the solution, but evaluation of this RAG application is very, very important, because we need to monitor the quality of the chatbot or RAG application. At the same time, the cost associated to it, how much cost it is taking, and then the latency. These are all monitoring level metrics which needs to be monitored so that it meets the business requirement. And last but not the least, governance and monitoring of LLM ops, the security, the data controls, access controls, and what content the LLM is trying to output. All these are very, very important, so that we try to monitor the governance of the LLM. So next we will go into the demo. And in demo, the topics for demo are walkthrough of how we can implement an LLM solution in Databricks. And then we will go over Mosaic AI and Vector Index. and then demo of the chatbot itself, and then how to evaluate this bot which we have deployed. So moving on to the demo here. So first I would like to talk about, so hope everyone can see my screen. And then the first necessary requirement before building the whole LLM solution is trying to understand what are the minimum requirements for building LLM solution in Databricks. The minimum requirements required are having a good compute cluster. So here the cluster needs, because it has a necessity of several libraries. So pre-installed libraries, there's no need of installing anything in Databricks, but most important is setting up a cluster with a particular runtime version so that it has all the libraries pre-installed which can support this whole LLM solution. So the cluster setup is the most important thing. Of course, like Databricks has a lot of documentation on what is the best suitable cluster for deploying the whole LLM solution itself. So once the cluster is set up, then next move on to the next important requirement for building an LLM solution. The next important requirement for building LLM solution is nothing but we need to set up the Unity catalog. So setting up Unity catalog here, for the interest of time, I have set up the catalog prior itself. So this is the catalog which supports the RAG application. And just seeing the catalog, what are the important things we need to set up is like the tables. It needs to have a specific schema and table structure, and volumes. So volumes are important because this is where the source data lies. So these volumes is where we can upload any nature of the document, let it be images, PDFs, HTML, docs, any kind of documents can be uploaded into the volumes, and then directly these would feed into the LLM. So there's no need of an external data source. Directly within the Databricks itself, you can maintain your source data, and also you can maintain the whole output of LLM till the endpoint. Everything can happen in a single interface. So volumes, I have uploaded some life sciences related documents over here, and most of the PDF and docs. So those are the source data set which I'm trying to process into the LLM solution. Then next, I would try to go over step by step how to implement a RAG solution. So first important thing is set up the whole configuration for running this LLM solution. So for setting up the configuration, just make sure that the schema is defined, the catalog is defined, the volumes where the source location of the data files are there, and from there, once the config is completely set up, then we can move on to set up the whole data pipeline. So before going into the whole specifics of data pipeline, why we need to do this, and then how the evaluation works, first I will show a sneak peek of how the bot would perform so that you can relate to this content very well. After seeing the bot and some concepts of bot, I can explain that each concept, how it is coming from this particular code components. So I'll move on to one of the bot and then showcase like how the bot would work. So this is one bot which is developed for life sciences use case, and then asking a specific question to a bot, like it goes and so here I'm typing in a question, which is one of the train data set for this particular bot, and then it starts generating the answer. So while it is generating the answer, so we can see how like each question the bot just tries to get the response out, and then in addition to the response, it shows like how many seconds it takes to the first token, and in addition to that, the total number of seconds it took to generate the whole response by itself. So here it took 17 seconds to get the whole response, and of course we can see that the response is definitely pretty detailed in nature. So here, like the question I have asked right now, it has generated response for that particular question, and then it took 20 seconds for the first token and additional 14 seconds. And then the most important thing is like there's a feedback loop integrated. So the feedback loop is very, very important because like initially, even before deploying it as a solution, as a production grade application, just at this POC level or to the stakeholder itself, feedback loop is very, very important because we need to know and understand from the domain experts that the bot is performing well. So for that, we can always go and check the feedback loop. Is this response good? Then ideally, if I say that it's a good response, then it asks why you have picked X to the stakeholder. So the stakeholder can mention like whether it's accurate, the response is relevant or professional or safe. It's very, very important to collect all these metrics from the stakeholder because it might be accurate, but it might not be relevant in some nature, or it is not safe. Like some content which the LLM is generating might not be safe. So we have to monitor each and every aspect of the LLM performance. So setting this, then that would actually go into the evaluation set of the LLM, and from there, a continuous feedback and monitoring can be established to improve and tune the performance of LLM day by day, and it performs well. In addition to that, it also gives the references to the PDFs. From where did it get the information? So this comes out by the metadata of the document itself. So the LLM process the data which has been uploaded into volumes, and then it also tries to document the unique URI for each document which we have processed, and it saves the metadata of that particular document. And then in for the question which the user has given, in addition to the response, it also fetches the metadata related to that particular document, which means that it can cite the source. So these are the citations from where it got the answer. And then even in the in the response and citation of the source, there's a feedback loop attached where we can always say that yes, it did get from the right document, and this is the right relevant response which it should give. So that way we can always collect the feedback at two levels, at the response level and also at the document level, whether it is getting the response from the right information. So that's how the bot works. So I would like to showcase the difference between a RAG application and difference between a normal LLM performance by itself. Why do we say that we can't use prompt engineering or we can't use the LLM right by itself? The reason being, the LLM doesn't know everything about a particular enterprise. For example, it's a life sciences company, then a normal LLM would have more generic information. It cannot have specifics of that particular information. So this is like a normal endpoint of that particular endpoint of DBRX, which is the same model which has been used for the RAG application. Here, the response definitely is good, definitely is relevant, but it is not as much detailed as possible, just like the RAG application. This is more like information which is coming out of Wikipedia or encyclopedia. And in addition to that, it cannot cite the sources. So the prompt engineering, definitely the LLM has very good knowledge base, but to perform at the enterprise and contextual level, definitely this helps. So we have seen that the nature of response using RAG definitely is more elaborate, relevant, and more relevant to the company level information itself. This is about one of the LLM, which is for the life sciences solution. Next, let's see LLM on another industry, which is financial industry. So here, the reason why I'm trying to show two different solutions over here is the infrastructure is the same, the platform is the same, the model is the same, and the whole endpoints, chunking, parsing, all the infrastructure is the same, but we can leverage it to n number of industries and use cases. So once the whole infrastructure has been built strong and the architecture level of solution is strong, then we can leverage, reuse the same infrastructure to any number of use cases. So that way, like the whole solution is efficient and cost effective. So here, asking a question back to the bot on a specific enterprise level information. So I have trained the bot using some of the financial data sets and financial industry information, and then it is trying to fetch the response. The same nature, it asks for a feedback loop, and then in addition to that, let's try no over here. And then why did we pick no? Is it inaccurate, or is it off the topic, not relevant, or is it poorly structured, or it is too long or too short? Everything is very very important in building the whole controlling the whole prompt response. So the response shouldn't be too short, too long. What is the end user preference? Do they want detailed response, or do they want short response? All this needs to be controlled at the code level so that we can frame the response in that structure. So it is very important to collect the feedback from the user. And then same way it tries to showcase the reference documents over here. So asking the same question to a normal LLM endpoint using a prompt engineering here. Let's see what it gets. So here the same question has been asked, and then the same model by itself, but it just gives like a definitely some response, maybe not so relevant as what RAG has provided. So this is the main difference on why we have to use RAG or fine tuning than compared to prompt engineering. So that's a quick overview of how the bot or RAG application can be built and deployed as a bot endpoint. So this endpoint, whatever you are trying to see here, this can be integrated as an API endpoint for front-facing applications. So using Next.js, React.js, or any of the front-facing application libraries can directly consume this API endpoint and then integrate that as a bot in a particular application. Not only that, this can also be integrated to a search to leverage as a semantic search. It can be used for any type of use cases, like just to summarize the context, or it can be used as a sentiment analyzer. It can be used as a semantic search by itself. So moving on, now we have understood like how the bot is working and what kind of response it is trying to get. So let's understand some deep technical concepts. I might go a little technical over here, but the purpose of the whole webinar is to go over and try to understand how to deploy an LLM. So here, the first thing is like I'm trying to configure the whole setup which I need. I have showcased like the catalog and all the necessary prerequisites have been set up for the LLM application. Next, I would go and make sure the config of my whole data pipeline. So here, I'm trying to showcase like what all configurations are needed for data pipeline. The first thing is like I need the embedding endpoint name. So here the embedding endpoint is Databricks GT large English EN. So this is the embedding which I'm trying to use for this LLM solution. And for the tokenizer, I'm trying to use one of the endpoint. This can be changed to or customized to any embedding or tokenizer of choice. There are lots of open source wide solutions, and then anything can be used. But here, for this particular application, I have used GT large English model. And then the tokenizer source is of course Hugging Face. And then for the parser, PyPDF, that is one of the popular parsing library for the PDF documents. So that parser has been used. And for the chunking, here for this particular solution, we have used LangChain recursive car. That's the chunker which has been used for this particular solution. Of course, parser is nothing but parse the whole PDF into a different split. It splits the whole document into different chunks, and then we can also control on how many chunks should be produced and what is the size of chunks as well, and the overlap of chunks. This is very very important. Most of the Gen AI community would understand like how important this is for the whole performance of chunking. So here, I have taken the default chunk size and default overlap. Didn't tune it, but definitely if the need occurs, and if we need to use any OCR on top of it, OCR is nothing but the optical character recognition. In case the source document has more images, more tables, then definitely we need to use more advanced other OCR libraries so that we can parse all that content. So that's the chunking. And then here the whole notebook, what it is trying to do, it is trying to pass in all the PDFs which I have uploaded into volumes, and then it tries to build the bronze table. Bronze table is nothing but the raw data set as is, and from there it parses all those documents and it builds the silver table. The silver table is nothing but the past content, and then it builds the gold table with the chunks. So let's take a look at how does it happen. So this is the first process which runs, where it takes each and every PDF which I have uploaded into volumes, and from there, this is the raw data set. It shows the length and other metadata, and also it tries to make sure the uniqueness of the document itself. From there, the step two runs, and then from the step two, what it does is like it processes this, and then from there you can see here that it parses the each document. So expanding this, you would understand that this document has 35 pages, and from there it passed into a structure where it can be converted into embeddings. So that's how it has passed this document. And after that, we are going to run our chunker. So running the chunk and defining the parameters for chunk overlap and chunk size, that would completely chunk the document. So here, the documents which I have processed, it produced like total of 630 chunks, and from there, this is the chunk test. So the whole past content is converted into the chunks over here. So if we need if to understand more, like we can always definitely go and try to see the chunks and then evaluate the chunks. Make sure that there's a lot of different varieties of how we can chunk the whole documents itself. It's a whole webinar topic by itself, which we would cover in future webinars. But chunking is also very important concept over here, and we can fine tune it to the greatest extent so that we can get good chunks so that the performance of LLM is good. So after chunking, then it will produce a vector index. So let me show the vector index. So after finishing the chunking, it built this index. And here the index, we can see like index has all the tags to understand what kind of embedding it has produced, what is the endpoint name, and what kind of data file format it is, PDF. It used parser PyPDF, and then the index is online, and it has totally processed the rows. It indexed is 630 rows. So the vector index can directly be queried to make sure that the vector has been indexed correctly. It can be directly queried using a query endpoint over here. So that's how the whole data prep would work. And after this data prep, the next thing we have to do is we need to deploy this as a application. So once all this done, the next step is to deploy this whole LLM solution into an application by itself. So I have conducted all these steps, converted the whole chain config. That this is the chain config. What is the vector search endpoint name? I have just defined the vector search endpoint name, LLM endpoint name, and then all other important config files converted into YAML, so that way like I can deploy this whole solution into an actual endpoint. So the vector search index name has been defined over here, and then from there like I'm defining my primary key, chunk text, and all that, and then trying to deploy this. And one more important thing which can be fine tuned in case the LLM is not working to the extent which we have expected, is fine tuning the LLM parameters by itself. Most of the GenAI community would know like setting the temperature and max tokens for input and output retrieval is very, very important for fine tuning the retrieved context and also the response. So those are the important parameters. Of course, for this solution, it has been set to the default parameters. So that can also be configured, and finally, it has been deployed as an endpoint by itself. So the serving endpoints, once I have run the whole code, then usually what happens is it deploys an endpoint like this. And then from there, it is a serving endpoint, which is in ready state. The health checks would confirm that it is ready, and then it can be queryable. So the same endpoint is nothing but the life sciences application, which I have showcased here, which we have queried and tried to see the performance of that particular LLM solution. So that's how we can deploy this endpoint. But the most important concept starts from here. Deploying is one thing, but evaluating that the LLM performs well is the next big thing to monitor. So here, I'm going to talk about like how we can evaluate the quality or nature of this particular LLM solution. So after the LLM endpoint has been deployed, what I have done is that I have built a particular evaluation set for that particular LLM. So where is this evaluation set being built? It is right next to all the other gold, silver tables I have said. There is one more table which was built to evaluate the performance of the LLM. So every feedback which we have received from a business user or stakeholder, then that feedback would be where it will be logged into this table, and from there it tries to see the performance of LLM. So here I would talk about the important metrics which are important to actually see if the LLM, the chunking, embedding, all these are performing well. So when we talk about how we can evaluate the LLM is working well or RAG application is working well. So the quality needs to be monitored at different levels, starting from the data pipeline. Is the data corpus right? Is the input, like the input documents, whatever has been processed, did they parse well? Or is there anything which is left over on parsing? Or is the chunks accurate? Is the chunking strategy accurate? And from there, is the embedding accurate? Do we need to tune anywhere in this data pipeline to make this performance better? So that way, evaluating the quality of the whole retrieval, evaluating the quality of the generation, and evaluating the quality of the whole chain as a whole, RAG chain as a whole, is very, very important. So here, the evaluation set is the data set which has been inputted into this table directly from, like, when the users are trying to ask questions and giving feedback, directly that feeds as a trace file into this table which has been built. So that traces and every question being answered is documented over here with the request ID and with the expected response. So that is being fed into this table, and from there I'm trying to use some of the ML flow functions, which are again native functions of Databricks, to evaluate the quality of this LLM. So here, after converting that, then I'm looking at a specific evaluation metrics for this particular LLM solution which has been built. So the first metric which we are trying to see here is judging the LLM on chunk relevance. How relevant are the chunks? And the even the judging of the particular chunks is done by precision and recall. So these are the popular evaluation metrics for most of the ML models. So checking the precision of the chunks, and then taking the precision value and then making sure that the chunks are relevant for that particular question and as well as the response. And the next evaluation metric I'm trying to see is the correctness. How accurate is that solution? How accurate is the solution which has been returned as a response? So here the correctness is 0.6%, because we have a very small data set and then a small number of questions processed. Sometimes these metrics might not be so accurate, but definitely we want to set a threshold on this. Make sure that the response correctness should be greater than 0.9%. So that way, like, we cannot take any false positives or hallucinations. And then in addition to that, the groundedness. How much grounded is the response of the LLM? So it is 0.96. And then relevance to the query, how relevant it is. And safety is that it's very, very important to monitor that there is no abusive, harmful, or unexpected content in the response of LLM. It's very important to monitor those levels and have that safety checks implemented. And in addition to that, like, is the context sufficient, or does it needs to provide more lengthy context or more short context? So context sufficiency is another evaluation metric which has been inputted. Then rating, and also trying to see the token count, like whether the input token and output token, how fast it is fetching. And then what is the latency? Is the latency metrics correct? We can set thresholds on each and every metric right here. and try to make sure that the LLM solution is working as accurate as possible. So that way, evaluating the LLM is very, very important, and these evaluation sets can also be maintained within the Databricks. So that way, we can monitor and start continuously improving the LLM so that it performs well. Just to review the whole LLM metrics once again in a better format, I would like to describe like each metric on how we can evaluate the LLM. Retrieval, we are trying to see the dimension retrieval and trying to see like is the chunk relevance accurate or not, and then it is measured by LLM judge. What is LLM judge over here? It is nothing but the Databricks AI agent. So AI agent is being deployed by Mosaic AI framework just to go and monitor the effectiveness of this model. DBRX is the foundational model which has been used. So that AI agent is going and trying to evaluate the DBRX performance over here. So it is trying to be measured by the LLM Judge AI agent. And again, on retrieval dimension, it is trying to evaluate the document recall. What is the percentage of ground truth? Like, is the chunks accurate? So it is trying to be measured by deterministic. Deterministic is nothing but by setting thresholds. So by setting the parameters, by setting the weights, by setting the thresholds, it is trying to see whether the documents have been recalled correctly or not. And then the next response, correctness, relevance to query, groundedness, and safety, all these are agentic evaluation. Agentic is nothing but the AI agents which are within the Databricks Mosaic AI framework. And then the cost, like what is the total count of tokens? Definitely the whole LLM cost is tied, very strictly tied and coupled to the input and output tokens. How fast the response is being fetched and how many tokens it took to fetch the response. So this definitely is being monitored. And in at last but not the least, the latency. So directly the endpoint might work very well. So this endpoint might work very well and it would fetch even between milliseconds or seconds. But when this has been integrated to the front facing application, is there any latency in that particular integration? Even that can be evaluated by setting up these evaluation metrics, and we can fine tune that as much as possible so that it performs very well. So these are all the evaluation metrics which have been implemented. So that makes the whole Databricks solution starting from source data sets, uploading the source data sets within the same platform. I have used Unity Catalog. From there, I have used several notebooks to build my data pipeline. I have built my bronze table, which is the raw table. Then I have built my silver table where it has the past content. Then I have built my gold table, which is nothing but the complete chunked text. And from there, like index has been built. So everything happened in the same single Unity Catalog platform. All the steps, and then these tables also can be immediately, we can see like, oh, what how did it store the data. So directly it can be seen within the sample data by itself. So I can see like what is the chunk text, what is the chunk ID, is it accurate or not. And after all these steps have been performed, then right away I can see that whether the models have been built accurately. So here, like the models which particularly for this solution, I can see that yes, my model has been registered, and it is registered in the model registry, and it is versioned correctly. So that way, like it can always monitor that the versioning of that particular model is accurate and it is maintained. And in addition to that, like I can also see that the model has been served as an endpoint. In addition to all the foundational model endpoints, I can see that the models which I have deployed have been served as an endpoint and they are ready state. So everything happens in a single platform where the end user, there is no need to go and use different infrastructures, but have everything in a single unified platform so that the lineage is maintained end to end. So that's how the whole Databricks solution makes the development of LLM, implementation of LLM, and also evaluation of LLM everything in the same platform. So that way it is easy to build LLM solutions, Gen AI solutions in Databricks. So that's the complete demo end to end on the Gen AI solutions. But in our upcoming webinars, we are going to take each and every topic in detail, like how to improve the chunking strategy, how to improve the embedding strategy, and how can we fine tune the LLM. So all these topics would be covered in our upcoming webinars. Thank you all for attending the today's concepts. We can move on to the Q&A session.
Thank you so much. It was a pleasure having you, Venkata, Jyothi, Katra. Thank you. This was very comprehensive. I hope everybody enjoyed it. I'm looking at the questions and answers, and I would like to go over a few that we have. We have, I would say 3.5. Let me start with them. The first one will be, Jyothi, if you can help us. Can Databricks support Hugging Face models?
Yes, definitely. Most of the Hugging Face models, which are available open source, can be directly integrated into Databricks. So here, the main thing is like even the model endpoints which I have shown, they are coming from Hugging Face endpoints. In addition to that, like there's several models over here which are exposed in Databricks, but they have been exposed as Hugging Face endpoints. So here we can definitely see that we can directly go to the Hugging Face interface and then see the implementation of the model itself. So any Hugging Face open source model can directly be pulled into Databricks by using few lines of code and then just building a reference. And then from there, RAG can be applied on that particular model. Databricks itself has many foundational models available, but it can also use any third-party models can directly be called into Databricks, even including OpenAI models.
Okay, thank you. What are the security measures that need to be considered?
Yeah, that's a good question. So most of the industries currently, LLM sounds great. This bot sounds great, but what about the security of the data, enterprise level data itself? So that is the hot question around in the market. So the solution by itself, like when the model endpoint has been called within the particular a private VPC connection or VNet or a private cloud, then the whole data by itself, the enterprise data which has been processed into the LLM endpoint stays within there. So the LLM endpoint itself cannot consume any nature of the data which we are training. Only some usage metrics might go out but there's no actual data which will be going out of the boundaries of Databricks. So, and having it set up as a private connection and also making it secure using HTTPS, that makes it more secure and more safe and secure in nature. In addition to that, Databricks documentation clearly states that it has highest level of security standards put in place, NIST as well as FedRAMP, where data in transit and as well as data at rest are all completely encrypted. So that way it makes it very secure to onboard the data into Databricks and build a LLM solution.
Okay. Number 3, is there enterprise data safe with LLM? And then if so, what are the boundaries?
Yes. Yeah, it's a continuation to the question where security and in addition to that, the data governance and data security. So the first thing is like having the whole solution secured in a particular private net, VNet or VPC. First makes it a secured boundary, so that way like the data is completely secured as a whole within the enterprise and within the particular tenant or within the cloud infrastructure. In addition to that, the additional security which can be put in place is additional governance which can be put in place is using Unity Catalog. So Unity Catalog can maintain the access controls. It can maintain like who can actually access, and even it can control what level of data each end user can access. In addition to that, like we can also control the access levels on who can manage and who can query or who can read or write. All these access level controls can be set up on Unity Catalog so that the data is secured. And tweaking the security of the LLM response itself can also be handled by the Unity Catalog on trying to mask some data. So having data onboarded as the Delta Lake tables on Unity Catalog, we can definitely have the capability of masking some content which LLM cannot retrieve back. So that level of security can be established. So that's the reason having the data onboarded as a Delta Lake table on Unity Catalog, we can always have that control of which data can be actually sent out and which data needs to be restricted. And even if we need user level of restriction, that can also be taken place on Unity Catalog by maintaining the permissions of role-based access.
Okay. And one that just came off the press is, how can we monitor and minimize hallucination?
Yeah. Another good question. Mainly hallucinations occur when the LLM has not been trained enough on the content which we are trying to process. In addition to that, to minimize the hallucinations, even after processing a RAG application and train the LLM with completely enterprise level data, there is a risk of hallucination when the chunkings are not accurate or when the embeddings are not accurate. In addition to that, the past content, it's very very important to evaluate the, that's where the evaluation metrics I have showed, where we need to evaluate each and every step, making sure that the parsing doesn't leave out any content from the document which has been processed itself. And the chunking strategies also, we have to make sure that if the basic by default chunking strategies are not working, baseline chunking strategies, we have to go for semantic chunking and more advanced chunking strategies. So that way we are trying to chunk every part of the document, so that way like hallucinations are less. In addition to that, like most importantly, the knowledge and end user training. So the prompt, the nature of the prompts which the end user can ask, we can also train that, because when the enterprise level data has been trained and then the prompt is completely out of the particular knowledge base, then definitely the LLM cannot fetch that answer, or it fetches the generic answer. So the nature of prompts and the training and the feedback loop is very very important to be established. So in case there is in the event of hallucination, of course every system is not perfect, so they might be hallucinations, but establishing this monitoring and feedback loops helps a lot. When in the event of hallucination, we can always give the feedback, and then that LLM can be trained to minimize this hallucinations. And most importantly, the indexing, embedding and chunking, these are very very important to have high quality, so that the retrieval and generation works very very accurately.
Okay. Thank you so much for addressing those questions. Appreciate it. I want to take a minute to thank all of the attendees here today. We really enjoy having you here. I hope you found this webinar productive. And if you have any questions, feel free to reach out to us. Also, I want to remind everybody that attended that we'll be sending or emailing the recording of this session. So you will have that. And if there's any other questions, just feel free to reach us out, and we'll reply to you as soon as we can.
Thank you everyone for joining the webinar. It was pleasure having you today.
Thank you.